Hi all. In this video, I am going to explain about the operators that we use in C. Generally, we have these many types of operators: arithmetic, relational, logical, bitwise, assignment operator, and miscellaneous operators. Let us see one by one. We all know what is arithmetic operation is. Arithmetic operation is addition, subtraction, multiplication, division, and we even do increment and decrement also. Increment it by a value and decrementing it by a value, which means 1, and modulus is also there. Now this is the symbol, operator symbol for addition, add, when we have two operands, which means two variables are there and we have a value for it. For an example, if A is the operand and B is the other one, and A is 10, B is 20, if we give A plus B, then the answer will be 30. It is then added. Same way, if we subtract, put the symbol as operator as minus the dash, then it becomes minus 10 because A minus B. In case if it is B minus A, it becomes 10. Next is multiplication, which is the asterisk symbol. So A star B equal to 200 because 10 into 20 is 200. Likewise, when you divide it, then it is B by A, which is 20 by 10 is 2. Simultaneously, when we do the modulus, you all know division and modulus is slightly different. In modulus, we'll get only the final remainder. So B mod A is 0, the remainder is 0, and we get it. And if we want to increment and decrement, we go with double plus and double minus. And there is one more important point in having this symbol, the place where you put it. Like if it is A plus plus, it is post increment. If it is plus plus A, it is pre increment. Say for an example, if it is A plus plus, it is post increment, which means 11. And if it is plus plus, like it is just going to be 10, and if it is plus plus 8, it will be 11. Same way for the decrementation process also. And there are shortened operators for these few symbols, for a few operators. Like you can write it as A equal to A plus B. If it is C equal to A plus B, will not have it. But if you have an operation to be done in which you have to replace the variable A by A plus B, then you can even write it as A plus equal to B. Same for the subtraction operator as well as for the remaining three operators. And these are the examples for arithmetic operators. Assignment and logical operators are proceeding in the next slides. Now for arithmetic operators, we have seen about addition, subtraction, multiplication, division, modulus, and incrementation process also. As I told, it is where you put it. If you put it as A plus plus, it is post increment. If it is plus plus A, it is pre increment. So the same thing, we are writing it as A plus B. So given it as 10 and 5, here the example is, so it becomes 15. When you subtract 10 minus 5, it is 5, and when you multiply it, it becomes 50. And same, you'll get the mod here. It has a division as 2 and mod is 0, and it is post increment and pre increment. We can see the difference here. So it is A plus plus and plus plus A. Plus plus A is pre-increment, where the value is incremented and then it is reflected. Okay, and if you replace this by C equal to A plus plus, then you will get it as 10. See, the example is given here, the same. It is just given as the variable name is alone given as variable 1 and variable 2, just for an understanding, and given the same answer, same value for, and hence here it becomes as post increment is this just 6, and it is pre-increment here. You can see and you can try it in the compiler also. And next is relational operators. It is double equal to, not equal to. These are the symbols. Now I'll explain this first and then I'll show with an example. Now we have two operators and two operands, and we have, if you want to check whether what is the relation between it is, then we can check it by this way. This checks the value of the two operands, whether it is equal or not. Say if A equal to 10 and B equal to 20, and I write A double equal to B, and the answer will be false. Same here. And likewise, A greater than B, A less than B, A less than or equal to or greater than or equal to is shown here. Next is the logical operators. So it is double AND symbol and double OR symbol, and this is the NOT. here we will be, these two operands will be checked whether it is non-zero value. If all the values are non-zero, both the operands have the non-zero value, then the condition becomes true. If it is both, any one is 0, then obviously it becomes false. Here in case of OR operator, even if one is a non-zero value, then obviously the condition becomes true. Next is called as the NOT operator. It is used to reverse the logical state. Say if we have a true condition, then it becomes false, and the opposite one. See, this is the example for relational operator and the logical operator. Relational is a double equal to b, a in like, which means if I have the value as 3 and 9, I'm just going to check whether it is same or not. It is not same, so the answer is false. And next is, we'll be checking OR operation, and it is becoming 1 because it is just the OR operation. And here this is greater than or equal to b, yes, it's true, and less than or equal to b, no. 3 is false. This is not less than or equal to 9, so it becomes false. And the same for a greater than b and a less than b. Next is the logical operator. See, a double equal to b and a less than b. A double equal to b is actually 0, and a less than b is actually 0. Both are 0, and hence it's 0. If both, even if this is 0 and this is 1, if we replace by a greater than b, then also the answer will be 0. Why? Because both should be non-zero value. Likewise, for the logical OR operator, a double equal to b or a less than b, it both are 0, so it is 0. But here if we replace this by a greater than b, here it is 1, so if we replace that by this value, even if one value is a non-zero value, we'll get the output as 1. Okay, and NOT operation, it is already 0 and this becomes 1. So this is how we make use of the operators, logical and relational operators. Next is the bitwise. The difference between the previous one and this is, we check bitwise, like a equal to 60 and b equal to 13 for an example. This is and bitwise and or XOR complement, left shift and right shift. I'll explain. See, we have these and equivalent values of 60. This is the binary format. So bitwise, if you check, and operation is if only both are 1, you'll get the answer as 1. And right now we are doing a and b, so this is 0, this is also 0, and this is 1, and this is 1. That's how we get it. Same way, 1 and 0 is 0, 1 0 is 0, 0 0 is 0, 0 0 0. So we'll get the answer as a and b equal to this. And if we do the OR operation, you know what is OR operation? 0 0 is 0, 0 1 is 1, and 1 0 is also 1, 1 1 is also 1. Likewise, we'll just try for this OR operation, a or b. So 0 1 is 1, yes, and 0 0 is 0, 1 1 is also 1, 1 1 is also 1. Yeah, we got it. Again, for this also, 1 0 is 1, yeah, 1 0 is 1, and 0 0 is 0, 0 0 is 0, yeah. And next is bitwise XOR. For XOR, what we do is, it is even if any one operand is high, then the output is also high. Even if both the operands are low or both the operands are high, then the output will become low. The logic is 0 0 is 0 and 1 1 is 0, whereas 0 1 or 1 0 becomes 1. So let us check it. So 0 1 is 1, 0 0 is 0, 1 1 is also 0, 1 1 is also 0, and 1 0 is 1, 1 0 is 1, 0 0, and 0 0 is 0 0. Yeah, done. Next is bitwise complement. We are complementing it. So you know the complement operation. We have to do 2's complement. Then we'll be taking the complement of A, then do the 2's complement, then that becomes the answer. Fine. Next is left shift and right shift. So we'll be shifting the value this way if it is left shift, and we'll be shifting the value by one way in the right shift. You can try. These are the examples. You can make a try either in the compiler or separately also. Next is the assignment operator. It is assigning. As I said, we even used this assignment operator in the previous arithmetic operation itself. A equal to a plus b. Likewise, here it is written as c equal to a plus b. Whatever you do in the right hand side will be equivalent to the left hand side operand. That's it. So that is why we assign it. For assigning that, we need c equal to a plus b. These operands and all, plus equal to, minus equal to, asterisk equal to, and all these and all we have seen already in the arithmetic shorthand operators itself. Hope you know. And here it is, if this case applies only if you have the operand both in the left and right hand side, then you can make it as, instead of writing as c equal to c plus a, you can write as c plus equal to a. And this is left shift assignment operator and assignment operator, and this is how same. Here we just replace it by c equal to c double left shift in equal to 2, in 2 is just written as t c double left equal to 2. Same way for the remaining also. Next is the remaining operators, whatever we have in the C. Size of operator, this tells us the size of the operation variable, and you can put it in that C compiler and make a try. This is the syntax of it, size underscore. And comma is one which it is a binary operator that evaluates its first operand and discards the result. Okay, and it can be operated as it can be used as both the operator as well as a separator. Next comes the most important one, the conditional operator. Here we have an expression 1. Instead of if else condition, we can use this expression 1 question mark, expression 2 colon, expression 3. This is the syntax. Now the case is such a way that the output will be, if you use this, the output will be such a way that if your if the expression 1 is the condition to be evaluated, then it is true. If in case the condition is expression 1 is false, then you'll get the expression 3. Instead of 2, you'll get the 3. That's it. If expression 1 is true, you'll get the 1 itself. If it is false, you'll get the expressions 3. Instead of if else, we make use of this conditional operator. Dot and arrow operator. Dot is actually applied to an actual object, and this one is to use to the pointer of an object. This is for casting an operator. Suppose I have any particular data type in my I have described about the data type in another video, you can check it. Suppose I have a floating data type but I want to convert it to an integer, then I can make use of this in the program itself, inside the program itself. I don't want to change the variable again, I don't want to change the name, I don't want to give another variable assigned to another variable. I can easily change it by doing this casting operator. It's very simple. The syntax is type and expression. In case if I have a variable, for an example a equal to 3.567, I just want to this is actually a floating variable, yes. Now but right now I want inside the program this a to be as a integer. So what I'll do temporarily, I'll just put it as int a. In that in that case it becomes a value of a, becomes a value of integer, and the answer becomes 3. Instead of 3.567, it is just 3. This dot is just full stop, ignore it. So it is just the 3 answer. If in case I have 3, let us consider another example, a equal to 3, then I want to convert it to float. Then what I have to do is a equal to 3, within bracket I'll write it as float, and a, then the answer becomes 3.000. So you can convert float to integer and integer to float also. And next is the remaining two operators. This we use in the pointers. One is going to represent or showcase or point towards the address of a variable, and the other one will be pointing the variable itself. So when we use the ampersand symbol, it will be addressing or giving the actual address of the variable wherever the variable is placed. Address, if you want specific address of a variable, then you have to put the ampersand symbol. If you put the asterisk near the variable, then it will point to the variable itself. Thank you.